Good morning, friends. In this video, we are going to discuss about very important area of power generation called nuclear power plant, which is the part of power plant engineering. The nuclear power plant is a major source of generation of electricity in our country, apart from coal-based power plants and other renewable energy sources. Nuclear power plant plays a vital role in our economic development and energy consumption level. When we talk about nuclear power plant, we should know the atom. That is a very basic concept. Everyone knows that. It is made up of proton, neutrons and electrons. The protons and the neutrons make up the center of the atom called the nucleus, whereas electrons will revolve around the nucleus in a small cloud. This is called an atom. So it is made up of three tiny kinds of particles called subatomic particles, namely protons, neutrons and electrons. Okay, nuclear fission, like any fuel undergoes a combustion process, it will release heat energy. In similar way, when the fuel in the nuclear power plant, what we are using is uranium-235, which is abundantly available in earth, but it is of only 0.7 percentage, that we will see later. So the nuclear fission, when the nuclear reaction, that is chain reaction, is taking place, it will release enormous amount of heat energy that will be utilized for converting the water into superheated steam. The most of the energy produced from nuclear power plant is derived from nuclear fission. First, we should understand what is a fission. The target nucleus must be fissile, that is, it will undergo sustainable nuclear chain reaction with slow neutrons. Let me repeat the important definition, important basic concept of this lecture. The target nucleus, that is atom, must be fissile, which means it is capable of sustaining a nuclear chain reaction with slow neutrons. The common example of naturally available fissile material is uranium-235, but it is not available in pure form in nature. It is present along with uranium-238, which comprises 99.3 percentage. That is, only 0.7 percentage is uranium-235. So we have to filter and we have to take only 0.7 percentage of the uranium available in the nature. In a fissile reaction, upon neutron irradiation, that is, the neutron strikes the nucleus of nucleus, an excited nucleus is produced, which divides into two main fragments along with the release of several neutrons. Please look at this equation, where the neutron irradiate with the nucleus of uranium-235, which will undergo chain reaction. So energy released during such a chain reaction is approximated as 6.56 million electron volt. 6.56 million electron volt. Okay. Now just we look at how the nucleus, that is how the uranium-235 is being prepared and how it is being implemented. In United States of America, 20% of the power generation is from nuclear power plant. It means 1 in 5 house in US gets electricity by means of chain reaction, that is by means of nuclear power plant. See, from the mines, uranium mines, they are taking the uranium 235, it will be ground and it will be filtered as we are seeing the picture, and the uranium ore will be converted to uranium hexafluoride and it will be converted to gas and solid by separate chemical reaction, and it will be enriched uranium as uranium isotopes. The picture shows the uranium isotopes and is encased in a solid ceramic pellets. Like this is the pellet, inside this pellet the uranium will be arranged. Now this diagram shows the fuel rods where we are inserting, we are putting the pellets, like loading the gun, revolver, loading the revolver, we are putting the pellets, nuclear pellets inside the nuclear fuel rods, and a bundle of nuclear reactor rods will be formed, and this fuel rod will be inserted into the nuclear reactor, which will undergo chain reaction and will release enormous amount of heat energy. Like revolver, we are putting the pellets. The fuel, as we have discussed, uranium-235 is the commonly available fuel which is available in nature, whereas other fuels which are also fissile material, plutonium-239 and uranium-233, but they are produced in the nuclear reactors. Please carefully listen. Uranium-235 is the only fissile nucleus that is available in nature, whereas plutonium-239 and uranium-233 are produced in the nuclear reactors. Plutonium-239 is used as a fuel in fast reactors, whereas uranium-233 is used in advanced heavy water reactors. Yes, this is the nuclear fission and the nuclear chain reaction. Now we are going to see the chain reaction. So look at this, when the slow neutron or neutron irradiate with the nucleus of the uranium-235, it will release two neutrons, and subsequently that slow neutron hits another atom of uranium-235, that is nucleus of uranium-235, which will release another two neutrons. So likewise the chain reaction will be sustained. That's why in the beginning we have seen that only sustainable fissile fuels we have to choose, otherwise it will not undergo or it will not sustain its chain reaction. So we have to choose the fissile material, fuel material, that is uranium-235, which will undergo sustainable continuous chain reaction when it is acted upon a neutron. So with this we will close this basics of nuclear power plant. In the coming sessions we will be discussing more about nuclear power plant components, nuclear reactors, what are the different types of nuclear reactors, all those things we will be discussing in the coming videos. Here we are seeing the last slide, we are seeing the very simple equation, uranium-235 plus neutron, it will undergo the fission reaction, it will release 2.3 or 2 or 3 neutrons, that is nothing but 200 million electron volt. Each neutron releases 2 more neutrons, then the number of fissions doubles each generation. In that case, in 10 generations there are 1024 fissions, and in 80 generations about 6 into 10 power 23 fissions. So that's why we are calling this as a chain reaction, which will not end unless we shut down the plant. Once it is loaded, it will run for years together. Okay. Thank you for watching this video on basics of nuclear power plant. Thank you.